Alright guys, so this lesson we're going to be talking about power. So what is power? So often we misuse the word power, force, or energy. Okay, so say if the object is not moving, right? Why is it not moving? Sometimes people say, "Oh, I don't have enough power," but no, you don't have enough force because force makes something move, right? Okay, so and then what is power? So power we first have to define. Actually, just come from this equation. Okay, so power is how fast energy is transformed. We talk about energy transformation. If energy can transform very fast, for example, if you have a car, right? If a car has a bigger power, it can create lots of energy in very short amount of time. So short time, lots of energy, that will give you a very big power. Okay, so then we say, well, this car is very powerful. It got a big horsepower, right? So the horsepower just means big horsepower means energy can be transformed really quickly, creates lots of energy in a short amount of time. Okay, all right. So if we say a power is small, say it takes a long time, a big denominator, you take a long time, big denominator, you only create a very small amount of energy, say, then you will have a power that is much smaller. Okay, so that's what power is. So when we use energy, we normally use the change of energy. Okay, so because how fast energy is transformed, or energy transformed is the amount of work done. So we can say how fast work is done. So you use work divided by time. Okay, if we look at the unit of power, well, energy's unit is joule, and time's unit is second. So the unit is going to be joule per second, or you can say joule second -1. Okay, or I can give it a new name to make it a bit easier. There's one person called Watt. So Watt is a person who invented the steam engine. Okay, steam engine is you boil the water, then you got steam, and then the steam will push a turbine, makes this engine work. So that is how originally we've invented trains. Say we invented cars, and we invented boats, and all the boats, all the old ones, we use steam to drive them. I mean, nowadays we got electricity to drive them, much easier and more convenient, or you got a petrol car. But back in the day, we use steam engine. Okay, so Watt is a person invented steam engine, and it's so important because he basically started in the industrial revolution in the 1700s and 1800s. So then in Britain, and then obviously that started basically this new modern civilization. So that is a big invention. Okay, so we use his name for power. So how to convert energy really quickly. Okay, all right. So then this equation we can rearrange it. Say sometime if they ask you what is the energy equals to, so then you're gonna say power times time. Okay, so that is the rearrange of this equation. If I want to know what does time equal to, and I can rearrange. Say, well, it's gonna be energy, change of energy divided by the power. Okay, all right. So in your book, and I give you example of calculating work. I say, well, you're running up the stairs, right? So you're gonna measure the time it takes and measure the amount of energy that's gonna be transformed. So we're talking about kinetic energy over here, and obviously, gravitational potential energy. Obviously, some energy is gonna be lost as heat, and we're ignoring that. Okay, we're only looking at the gravitational potential energy, and the heavier you are, and the faster you run, then you're going to be using more energy. If you're using more energy and then you're using less time, you will have a bigger power compared to someone who is very light, so using less energy, and then run very slow using a bigger time. Okay, so have a look at that question. So I want to run one example for you guys. So if we look at a power station, right? So say a power station, that normally will have something like this. Okay, say this power station we have, it tells you the power is 300 MW. Okay, this M is standing for mega. Mega is a million, so that's 10 to the power of 6. Okay, million watt. Okay, and I want to know how much energy in terms of joule does this power station produce? Because if I know that, and then I can find out, well, how many households it can supply. And so in all power station will have this number. Say, for example, a Huntley power station. So from memory, if I didn't remember it wrong, so I mean, it's definitely the biggest power station in New Zealand, and it's using coal and natural gas to burn them to create energy, okay, and to create electricity, and they produce 14% of the New Zealand all energy used in New Zealand, okay, and that's a very big power station. For memory, I think it's 1,200 million watt, okay. So let's say, well, this is a hydroelectric dam somewhere in North Island or South Island. South Island, we've got a lot of them. So let's say the power is going to be equal to this much. And then the question is, how much energy does it produce in 1 hour? Okay. All right, so now I need to write down the information I know. Well, so I know P equal to 300 m watt. And I know time equals to 1 hour. Okay. So from the equation, I can know that, well, the energy produced can equal to power times the time. Okay. So I need to put the numbers in, but the number I need to change it a little bit. So if it's million watt, so it's going to be 300 million watts. Okay, and then 1 hour, I will need to change it into second because the unit I use will be the SI unit, which is second. Okay, so that equals to 1 hour got 60 minutes in it. So now I got 60 minutes. And then each minute has 60 seconds. So now how many seconds do I have? 3,600 seconds. Okay, so now I can combine these two information together. 300 million times 3600. And then I can put that into the calculator. It's going to become a really big number. 1.08 times 10 to the power of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 joule of energy. That is the amount of energy we can produce from this power station in 1 hour. Okay. If you want to find out 1 day, you times this by another 24. And then if you want to find 1 year, you times that by 365 again. So then you get how much energy can be produced. Okay. And most of the questions, you are just going to be using this to calculate power. Okay. So you say, well, I found out work through the question you've done before. I found out work. Now I just need to divide by time to get the power. Okay. So, but if it goes backwards, when you calculate energy, then you can use this method to calculate it. Okay. All right. So that's it for our lesson. So basically, this is the last topic, and after you finish this topic, you can do the assignment. And our class is a little bit behind the other classes. So the schedule is we're gonna finish this and then start like static electricity. So that's why I'm just posting all the things on the internet at the moment. So hopefully you finished energy transformation. So today you should be working on you finished like what else? Work. You finish work as well. So now obviously you're gonna be, if you're watching this video, you'll be working on power. So silly me. Yeah. So hopefully you've done this like within the next within this first week and second week. And then next one, you finish the assignment, and then we're gonna move on to static electricity. Okay, so our goal will be starting static electricity within the first week, so you guys can pace yourself, and if you can do a lot more work now, that would be the best. So I'm just gonna post how much information we need to give you guys for this whole 4 weeks when you're at home, so you can just take your time and as it fits you. Okay, so yeah, so I think I'll prefer you guys to finish this before the 2 weeks break. So if you are gonna have a break, and then when you come back, say the first week when you're at home, so then you'll be working on static electricity for 1 week. I think that would probably be be like great. Okay, yeah, but for me is I'm gonna be working throughout the 4 weeks, so yeah, so I think if you can do that, that would be brilliant. So the principal has given us a message say not to overwhelm you guys with like lots of work. So just like pace it out. Say we give you 1 week of work, so you work 1 week, and then we give you another week of work. So in week 4. But I personally just prefer to give you guys all of it, so then you can take your time whenever you want to do it. Okay, because I prefer to get work done first, and then I can have some break later. So it's up to you guys. I'm just gonna be posting this on the internet as we go. Okay, all right, so have a good day, guys, and stay safe and work hard. So if there's any questions, send me an email as always, and then I'll run through the questions with you guys. Okay, all right, have a good day.